Welcome to the AHACL Senior Design Team's Expo poster presentation. My name is Nicole and I am the project lead. During this presentation, we will explain the purpose of our project along with the performance specifications, our design, expected outcomes, and implementation. Our project title is the Biomechanical Analysis of Supplemental Tibial-Sided Fixation for ACL Reconstruction. Our industry supporter is Atrium Health. The purpose of our project is to design an apparatus to test supplemental graft fixations through cyclic and pull-to-failure material testing. Maddie will now present the performance specifications.
Our team was required to create an apparatus that met the following specifications. We needed sensors that would be able to measure the alignment angle as well as the local and the global force and displacement. We were also required to create a LabVIEW and a MATLAB program, which would be used to analyze the raw data and create graphs and charts to be further analyzed. A tibial tunnel would need to be secured and aligned parallel with the load. Edward will now explain the expected outcomes.
The team is expected to produce an apparatus that securely fixes a tibia and the graft for cyclic and tensile loading tests. You can see at the bottom left of the screen the LabVIEW block diagram that is used to process the data for analysis in MATLAB. The graphic user interface generated by MATLAB is used to visualize results like stress and strain, as shown in the bottom right figure. All hardware assembly and software development of the apparatus is calibrated such that it is reliable and durable for multiple tests. And now Hugh will discuss design.
So design consists of a PVC holder to hold onto the tibia specimen. There are clamps to hold onto the femoral side of the bone tendon bone graft. There will be a tibial alignment device to align the tunnel to the worst case scenario, which would be parallel to the force. And there will also be LabVIEW and MATLAB code to record and analyze data. You see on the right the tibial tunnel alignment device being used. Those two screws are at each end of the hole, and when used in conjunction with the accelerometer and Arduino, it can specify the pitch and roll to identify the best angle. On the left, you'll see the MTS adapter, load cell clamps, and then the tibial side of the apparatus. The adapter connects to the piston of the MTS machine. The load cell will record the local load, and the clamps will be holding onto the bone plug. On the right, you'll see a close-up of the tibial side of the apparatus. There will be a tibial holder block to hold the specimen. The set screw will hold the specimen in place at the PVC to prevent slipping. The carriage bolt allows the specimen to be rotated during alignment. The LVDT holder holds onto the LVDT to measure displacement, and the mounting holes to the XY slider allows the whole apparatus to be mounted onto the XY slider provided by Atrium. And Storm will now discuss implementation.
So our team was able to complete a working prototype as well as complete a successful pilot test by the April deadline. We are also on track to deliver a working apparatus final report along with the user manual to Atrium Health IMA.